Hey YouTube, welcome back to another tutorial. In this one, I'm going to be teaching you all about the Pascal's triangle again. This is the second part of the Pascal's triangle problem in Leetcode, and I'm going to be teaching you how to solve it. So let's see what the question is asking, and I'll get into solving it right after. So given an integer row index, return the row indexed, zero indexed row of the Pascal's triangle. In Pascal's triangle, each number is the sum of the two numbers directly above it as shown. So let's get into this first part here. Given an integer row index, return the row indexed zeroth row of the Pascal's triangle. Basically what this zero indexed means is we're going to be counting from zero. So this is going to be the zeroth row, first row, second row, third row, and fourth row. So how does the Pascal's triangle work? Well, I explained in my last video. And if you aren't familiar with the Pascal's triangle, I'd suggest you do a bit of background research, but that's okay if you haven't. Basically what Pascal's triangle is, it's a geometric arrangement where each number is the sum of the two above. So if I'm looking at this 3 right here, it's the sum of this 1 and this 2. Alright, so let's look at the examples. Given an input of row index equals 3, we're returning 1, 3, 3, 1. So if we look at this, we go 0, 1, 2, 3. It gives us 1, 3, 3, 1. If the input row index is 0, we're returning 1. And if the row index is 1, we're returning 1, 1. And we're returning this in an array. Last time we used a 2D array because we were returning the whole pyramid. This time we're only returning a row, so it can be in an array. And the constraints are row index is greater than or equal to 0, and it's less than or equal to 33. So how are we going to generate one row of the Pascal's triangle when we don't even have the row above to calculate, right? That's what was going into my mind the first time I looked at this problem. I thought maybe there's a way we could generate the row above but that wouldn't really make sense because you would need to generate the row before. So the only way to do it is if you can find some sort of pattern within the Pascal's triangle, which could solve that for you. And that's exactly what I did. One thing I learned after solving our last Pascal's problem is that you can solve the Pascal's triangle using combinatorics, especially the choose function. So I'm going to show you an image right here, which might just give it away entirely. But as you can see in this image right here, we can calculate the Pascal's triangle using n choose k. N being the number above, k being the number below. And using n choose k will give us the value at each specific point in the Pascal's triangle. Now, why does this work? So n choose k is also what's known as the binary coefficient. And what it means is the number of ways to choose k elements from a set of n elements. And the order doesn't matter in this case. So let's go through this row by row and I'll explain to you how n choose k works. Let's say we start off here at the 0th row of the 0th element. 0 choose 0 is 1, because let's say we have 0 socks. How many ways can you select 0 of them? Well, there's only 1 by not doing anything at all. Now let's move on to row 1. We have 1 sock. How many ways can you choose 0 socks? Well, there's only 1 way. Now we have 1 sock. How many ways can we choose 1 sock? Well, again, there's only 1 way. Next we have row 2. So we have element 0 in row 2. So given 2 socks, how many ways can you choose 0? There's only 1 way. Given 2 socks, how many ways can you choose 1? There's 2 ways now because you can choose either sock. And given 2 socks, how many ways can you choose all 2? And there's 1 way. And this is going to be the last row I do. Hopefully you're picking up on the pattern. Given row 3, given 3 socks, how many ways can you choose 0? There's 1 way. Given 3 socks, how many ways is there to choose 1? There's 3 different options, so that's 3 socks. Given 3 socks, how many ways are there we can choose 2 socks? And there's 3 different ways. 3 socks, how many ways can we select 3 socks? And there's only 1 way, which is by selecting all 3. I hope that explanation made it simpler for you to understand why this relationship exists in the Pascal's triangle. But let's go ahead and code it. The first thing I'm going to do before I start coding is I'm going to code a choose function, a function which calculates the binomial coefficient for me. And I'm going to call this let choose equals nk and this is going to take our n, which is our row, and our k, which is the item of each row. Now, what is the combinatorial formula? And here we are, first result on Google, n factorial divided by k factorial times n minus k factorial. So first thing we're going to need is a factorial function. So I'm going to create that now. So we'll say let factorial equals n. And I'll start with a result of 1. And I'll say for let I equals 2. I is less than or equal to n plus I. Result times equals I. Return result. So what am I doing here? Well, what is a factorial? A factorial is the product of all positive integers less than or equal to n. Let's say we're given an n equals 6. We're going to return 6 times 5 times 4 times 3 times 2 times 1. And we're actually going to get rid of this times 1 just for efficiency, because anything times 1 is the same number, so we don't have to include it. That's why this for loop is starting at 2. What it's doing is it's taking our result, which starts at 1, and we're just multiplying. This should be times equals, not plus equals. And it's taking our result and just multiplying it by each integer that leads up to n. Now for the combinatorial formula, all we're going to do is simply code it the way we would write it. So we're going to use our factorial function of n. So factorial k times factorial n minus k. Now that we have a binomial coefficient calculator with our choose function, how are we actually going to implement it? Well, first we need a row that we're going to return in the end. So I'm going to define a row as an empty array. Now I'll say for let I equals 0, and while I is less than or equal to row index, something that I taught in our last Pascal's triangle solution was that the row index is actually the same as the amount of rows in the triangle. So whenever you're doing a problem like this, you need to think, is there any sort of additional piece of information that I can use to help me solve this problem easier? So if you're really looking at the Pascal's triangle, you would realize that each row has the same amount of elements as the row index. And that's why we said I is less than or equal to the row index. Now we increment I, and I'll say row dot push choose row index and I. So what am I doing here? We know that each number is n choose k in the Pascal's triangle. So we're basically pushing the row index, which is the n value, the row, with the k, which is the placement in the row, aka the number of different ways you can choose. And then lastly, we're just going to return row. Now let's submit this code. And you'll see that our submission was accepted right away. Now let's go over the time complexity and the space complexity of this. So firstly, we have one for loop where we're looping through the row index. So that's O of n. But we also have this factorial function here, which is also O of n. So we have two loops. This factorial function is being called 3 times in this function, which actually doesn't matter because O of 3n and O of n is the same. But when we have O of n times another O of n, that gives us O of n squared time complexity. The space complexity is just O of n because we're storing everything in just one array. So I hope that makes sense. But that's going to wrap up the video. Be sure to like and subscribe if you learned something, although you don't have to. It would help out the channel a lot. But I'll see you guys in the next one, and I'm out of here.